Hi, and welcome to the first talk of this track today. My name is Felicia and I'm a machine learning engineer at Solita. And today I will bring you on a journey through a field in AI that might not be as well known as other fields. And that field is reinforcement learning. We'll start by doing an intuitive introduction to this field, just so you get the feeling of the ideas behind it and how it works. And then we'll look into how it has evolved over time. And then we will start discussing industry, how you actually can apply it and use it in industry today. And we'll end with some notes on the future and ideas where this field might move into in the future. But we'll start with just a quick introduction of myself. As I said, my name is Felicia Fredriksson, and I am a machine learning engineer at Solita, where I work with everything AI and focus on bringing AI solutions out into the industry and actually making an impact. And before my time at Resolution, I also worked as a machine learning engineer in the gaming industry, where I actually worked a lot with reinforcement learning. And I also have a background in academia, where I did my master in machine learning and image analysis at Uppsala University. But I think that's enough about me. I think we should dive into the really interesting stuff, which is, of course, reinforcement learning. So what is reinforcement learning? Reinforcement learning is a field in AI that is focused on answering one particular question, which is how can we teach an intelligent agent to make a good sequence of decisions? And the key words in this question is really good and sequence. Because in order to make a good decision, you have to have some sort of goal. What is good, what is bad? And to make a sequence of decisions, this is indicating that you have to plan far ahead into the future. And this is actually quite difficult to train an AI to do. And reinforcement learning has taken an approach that is very close to heart to humans, which is trial and error. Try something, see what happens, and then you learn from it. On top of it, we add on a reinforcing signal. And you can see this signal as very similar to how we train our animals today. Whenever we see a behavior that we like and we want to see more of, we will give them some sort of treat or reward, which is reinforcing that behavior. And it's the similar idea that we see in reinforcement learning. And in order to train these models, you have to have a few specific components that you don't really see in many other areas in AI. And these components are first an agent, and this is our decision maker. We then also have to have an environment, which in loose term, you usually say everything else surrounding the agent. And finally, you have to have some sort of goal, like I was mentioning. You have to have some sort of behavior or problem or task that you want to solve. But I do realize this might be quite difficult to understand if it's the first time you're hearing about reinforcement learning. So let's look at an example. Let's say our agent is Pac-Man. Then our environment is probably looking something like this. And if we want our Pac-Man to win, the goal is obviously to get a really high score and to avoid the ghosts. And our agent and our decision maker can make different actions in the environment. And for Pac-Man, that is moving around in the environment and in which direction you should move. And depending on what the agent is doing and what actions it's taking, and also during time, the environment can actually change. And you say that the environment ends up in different states. And for Pac-Man, that can be when he moves, or maybe when the ghost moves around in the environment. And for the goal, the way we will convey this to our Pac-Man or our agent is by using a reward or a reward function. And the reward will reflect our goal, and the agent's goal is to maximize the reward. So with these components, we can actually start training using this RL loop, which is the training process in reinforcement learning. That's when the agent will take an action, the environment will then react to this action, return the state it ended up in, and also a reward. The agent will look at the state and it will try to maximize the reward. And then by doing this iteratively, over and over again, after a while, the agent will actually start to learn which action it should take in all the states in order to maximize the reward. And this information is stored in the policy, and it's often denoted by pi if you look into literature. So the policy in the end contains all the information we need how to act in every single state in order to maximize our reward. And since our reward is reflecting our goal, we will achieve that goal. And in the end, the policy is more or less a rule book, how you should act in the environment. And it's actually that we will use as the trained model in the end. But of course, these are hard concepts. Let's look at an example. And to help me with this, I will use some resources from AI Warehouse on YouTube. And they're really doing a lot of great content in the AI space. So check them out if you're interested. And they have this little guy called Albert. And Albert, he can move his body, but he doesn't know how to walk yet. And that's why we're here, and that's the task we will solve with reinforcement learning. He lives in a 3-dimensional room with a green square further away on the floor. And this is our environment. So as the first step, we have to formulate our reward. So let's do it easy and just say, as long as he's learning how to move his body closer to the green square, he will get a small positive reward every time he moves closer. Because after a while, he should figure out that if he walks over there, he maximizes the reward. And then we let him train. And after a while, we actually see him solving this task. He's maximizing the reward. The problem is that he's doing the worm. And that is super cool. I'm not going to argue with that. But it's not walking, is it? So what we see here really is that our agent doesn't really understand what we're trying to convey with our reward. So the reward is not reflecting the goal here, which is walking. So then we always have to change the reward. So one idea is to add a penalty every time he hits the ground. So then he has to stay upright and move closer to the green square in order to maximize this reward. And then we let him train once again. And after a while, we can actually see him take a step, but he falls quickly. But we let him train and continuously test things, and after a while, he figures this out as well. But he's skipping his way through this court. So once again, we're realizing we're not making him walk, we're making him skip. So we have to look at our reward function again. So now we'll add on a positive reward for every time he alternates between his feet, so left and right. And then we let him train. And we actually see after a while that he's managing to walk. He's wobbly, but he's walking. And they also add on some noise with these red cubes to make him a bit more robust. But what I wanted to show you with this sequence is that they actually managed to teach him to walk pretty firmly and even turn corners. And we come quite a far way from the worm that we saw in the beginning. And all of this was done using this reinforcement learning approach with a really well-formulated reinforcing signal, which is this reward function I'm talking about. So I hope now that you feel like you have a bit more of an understanding behind what this field is really built upon and the ideas behind it and how you train the models. Because now we're going to look into the history of this field and how it has evolved. And really, really early on, we can actually see a lot of the ideas behind reinforcement learning in other areas of science. So in psychology, we can see it a lot being inspired from how animals are trained and how they are learning different behaviors. Specifically, a lot of how you can modify behaviors using reward and punishment. Also in cybernetics, which is the science of control and regulation of systems, we can see a lot of inspiration from how systems process information and then makes decisions from that information. So all of these are sort of combined early on in the 1900s into the ideas that we now see being applied in AI and computer science. And in the 80s, we could really start to see this field form. And reinforcement learning is largely based upon the work of mathematician Richard Bellman. He did a lot of research on how agents could make decisions in uncertain environments while trying to maximize a reward function. And this is laying a lot of the groundwork that we see in reinforcement learning today. And it was also during this time that we saw reinforcement learning become a distinct approach to machine learning. And of course, a lot has happened since the 80s up until today. and I will only bring up a few milestones over the years just to show you what has happened in the field. In the 90s, a lot of the focus was really focused on taking this math and applying it and developing different algorithms and different approaches to reinforcement learning. So we have a lot of algorithms like Q-learning, autocryptic, and so on being developed during these years. And it's also really hard to say when a certain field arose, but around the same time, around 2000, we see deep reinforcement learning being more and more established as a field. And deep reinforcement learning is when you combine neural networks with reinforcement learning. So the policy that I was referring to earlier is now replaced and becomes a neural network. And the reason why this field has become so big is because now we're utilizing neural networks, and we can now use them to make more complex behaviors, and we can train and solve more complex tasks. In 2003 as well, we started to see some benefits, and we started to see some fruits from this labor we saw earlier on, where a reinforcement learning model learned how to play backgammon at the superhuman level. And I'm sure many of you have tried backgammon before. So you have to have some sort of strategy, you have to plan ahead, you also have to take in the uncertainties of your opponent in order to win the game. And training a reinforcement learning model to a superhuman level was quite an achievement at the time. Then we skip forward quite a few years until 2015, and that was when DeepMind released their DQN model that managed to play Atari 2600 games at superhuman level. And this was a huge milestone in the industry. And the reason for that was really that this was the first time that we could see a model who could actually play multiple different games at a superhuman level without being specifically programmed to one game. Before, we had to be much more controlled and focus on just one task to train the models. But here we saw some generalizability that we hadn't seen before. We also saw that they can handle really high-dimensional states and high-dimensional environments and still solve quite difficult problems. So this was actually a huge accomplishment at the time. And just a year after that, DeepMind also showed AlphaGo, which is a reinforcement learning trained model that actually beat the world champion in the ancient Chinese game Go. And Go is sort of famous for being this very abstract strategy game that was super hard to train AI on. And this became quite a buzz in the field that we were able to train a model that could beat the world champion. And this was trained using a combination of deep reinforcement learning and model tree search. A few years after that, in 2018, we also saw OpenAI release OpenAI 5, which is a team of 5 neural networks that are trained with reinforcement learning to play the game Dota 2. And they actually play to quite a high level, where they actually beat a lot of professional humans teams. And this is here just to show us how far multi-agent reinforcement learning has gotten, where these neural networks now has to be trained to cooperate with each other in a very dynamic environment. And in 2020, we saw Codex being released, which is an AI that can assist you with writing code and help you with different tasks, and it's based on natural language instructions. And this is not purely reinforcement learning, but it's used in the process to train this model. So this is here to just show us this shift towards combining reinforcement learning with other areas in AI. In 2024, we also started to see, both in reinforcement learning specifically, but in AI overall, that we're now starting to shift the mindset to design AI models that no longer has to beat us, they now have to assist us and help us in different tasks. And one example is in Minecraft, where they actually build models using reinforcement learning to assist players if they were doing complex tasks in the game. And of course, I can't skip mentioning DeepSeek R1 that was released earlier this year in January. And this is a large language model that is utilizing reinforcement learning to enhance their reasoning capabilities. And this is not a new idea, but the reason why this was so successful is because they have replaced human feedback with reinforcement learning to speed up the process and make the model more efficient and fast. And what we really see here over the timeline is actually that we started out really early in this field to just develop different algorithms. Then we had a few years where we were sort of trying to prove these algorithms were working, how far they could go, and that they could beat us as humans. But now we're sort of shifting the mindset back to now incorporating them into other areas of AI and to assist us as humans instead of beating us. So this is sort of the journey that this field has been on. But now I think we have to see some hard evidence how this is working in industry today. And I think we should always start with an example. And we'll look into Google and DeepMind's work, where they were looking into controlling cooling systems at Google's data centers. And the problem they were having was that it costs a lot of money to cool down data centers today. And the idea was really that maybe if you optimize the cooling system, you could save some money and cut some costs for the company. And one of the solutions they explored was training a reinforcement learning model to optimize the cooling system and maintain the temperature they wanted at the same time. And we'll have a quick look at just the setup for this training process. For the states, they were now made up of all of the different sensor readings. So you have the temperature inside, outside, humidity, the activity of the equipment, and so on. For the actions, they were now made up of all of these different small components in the controlling system of the cooling system, like condenser water flow or chiller temperature. So all these different things that you can tweak. And the reward was made up of penalizing all the energy consumed by the cooling system. And then you had a large penalty if you went outside of 20 to 25 degrees Celsius. And the reason for this specific range was that that was the range they decided was comfortable for the workers at the data center. So with these components, they were training the model. And we'll look at the results briefly from their paper that they published. And here we see in the plot the savings in percentage when the AI was being tested controlling the cooling system. And they were testing it for quite a few months, and we can actually see the savings increasing during this time, meaning that the model became better and better at controlling the system and minimizing the energy consumption. And in the end, we see almost a 30% reduction in energy consumption, which I would say is quite phenomenal results. And this is just one example where reinforcement learning was applied to a real problem in industry and actually managed to improve it. And Google today have an AI model controlling their cooling systems for their data centers. There are obviously many other industries that are exploring reinforcement learning at the moment. I'll just give you some ideas today, and then you can research even further. In medicine, we see reinforcement learning being explored for treatment planning and identifying high-risk states for patients in their treatments. In trading and banking, you can use it in many different areas, but one really popular one is portfolio management, where you let your model, your RL model, act on the market for you, maybe with specific constraints for your specific portfolio, and trying to give you the highest return possible. We also have Netflix, who is exploring reinforcement learning for recommendation systems, where they have very specific time budgets for their users. We also have games, which is a very natural place to apply reinforcement learning, and we've seen many examples in the timeline today. But a lot of companies are exploring it at the moment, and King is one of them. They're doing a lot of research on AI, and one of the fields they're looking into is reinforcement learning, where they're using reinforcement learning to speed up the testing process when developing new levels. We also have in transportation, it's a very common used in autonomous driving and for decision making with self-driving cars. But you can also use it in other parts of transportation, perhaps path planning, trying to optimize the transportation path with constraints on fuel consumption, for instance. And then we also saw an example from energy earlier on with Google, where we optimized a cooling system to minimize the energy consumption. And in these kinds of problems, reinforcement learning has really proven itself to be quite useful. And I do realize it's really difficult to know when you can use reinforcement learning. And if I had the answer, I would give it to you, but I don't. So I can't help you there. But what I can do is that I can sort of guide you on your way when you're having a problem. So we'll look at 3 questions you can ask yourself if you have a problem to see if reinforcement learning would even be worth looking into further or not. And if you get yes to 2 or more of these questions, then you could continue explore reinforcement learning to see if it could actually help you. And the first question is it really hard to teach the actions, but it's quite easy to score the actions? The second question is, are there a dependency between the states and what happened previously in a previous state or the previous action? And finally, do you require a lot of strategy and long-term planning and coordination in order to solve your problem? So if you look at these questions when you have a problem, this might give you some guidance of whether or not you could use reinforcement learning. So if we look at the Google example, why was reinforcement learning a good choice here? We go back to our questions. First of all, is it hard to teach the action, but it's quite easy to score them? If you want to optimize a cooling system, I would say you have to be pretty phenomenal at thermodynamics in order to know how to tweak all of these different things to optimize it. But it's quite easy to see if you're using a lot of energy, or if the temperature is already too high and you're turning it even higher, you can quite easily see that that's not a good action. So I would say yes to this question. And then we should look at the second one. Is there a dependency between what happened previously and what is happening now in the state, in the environment? And whatever I'm doing with the cooling system 5 minutes before this moment will obviously affect the thermodynamics and the temperature in the room right now, and also the energy consumption. If I turn it up, it will go up. So we have a clear dependency here as well. And finally, the last question. I don't really see you have to have some long-term planning or strategy. You have to have some coordination. So I would say no or maybe on that one. But overall, we can see with these questions that it's actually indicating that reinforcement learning could be helpful here. And as we saw in the result, it really was. So I hope this will help you on your way if you want to explore reinforcement learning further. And finally, the future of this field, my own speculation. I will just leave you with a few points that I'm thinking is the next step for this field, and is already ongoing, actually. First of all, we've seen it that we're now starting to integrate deep reinforcement learning with other fields in AI, trying to improve algorithms or find new algorithms. We have seen it a lot with GenAI, but I think we will continue to explore this with other fields of AI as well, and just try to reap the benefits of reinforcement learning, but still find new and other ways we can tackle different problems we're facing today. And an issue we're seeing in reinforcement learning is really this bridging the gap between simulation and reality, because we often see great results in simulation, but when you bring it out into the real world, you have a lot of uncertainties, and it might not perform as well. We saw a lot of examples from industry today. One of them is Google. So we're starting to bridge this gap and actually proven that you can use these algorithms and models in the real world. But I think this work has to continue and try to prove that you can actually use it in the real world for real. And I think it will also help us to build trust to these models so we actually dare to use them in the future. And finally, I would also say that if we ever want to develop AI models that will display human-like decision-making or human-like behaviors, reinforcement learning is the field we'll find it in. And I think it's here we will find the answer to how we can actually train those models and probably combine it with other fields of AI. And I, for one, is super excited to see where it will take us. And with that, I just want to thank you so much for your time. I hope you feel inspired to dive deeper into reinforcement learning. And if you feel like discussing reinforcement learning, you have questions, or you just want to talk AI, don't hesitate to reach out. I am always happy to talk about AI. And I wish you a great continuation of your day with great talks, and thank you so much.